Uh, Eric Darling here, with Eric Darling Data, and this is a post that I was originally gonna sit on for a little bit, but there, I'm gonna strike while this iron's hot. There have been a couple blog posts recently about using column store indexes to speed up count queries, and I figured I'd present something a little bit more broadly applicable than just counting rows in a table, and this is sort of a two-part thing, right? So this can work for either like the kitchen sinky catch-all type query, and sort of by extension paging queries, because they often go hand in hand, right? Like at one point you're like, oh, I got to select all this, I got to like give people this dynamic where clause and sorting, and then you're like, well, I don't want to show them a million rows at once. I'm going to let them page through this data. Now, the catch-all query type stuff, I think Kimberly Tripp has probably, I mean, like if not the best, then like like a tie for first post on the best way to write store procedures with that sort of catch-all element to them, right? Where like doing this stuff sucks, and you can see in red here they're going to perform horribly, and of course Kim is right because Kim is always right. So there's that, and then she goes through like some very thoughtful exercises with like recompiling sometimes if the different criteria gets met in the where clause, and then this other thing where you sometimes use SP execute SQL and sometimes use exec. And I think that I've written this store procedure like to the best of my ability in a way that honors that, right? Like I'm not going to recompile sometimes because I'm not going that far, I'm not going there with it. I'm going somewhere else with it. But as far as like building up the where clause and like filtering and stuff like that, I think in like using SP execute SQL, I think I've done like as much justice as I can to Kim's post about how to write this store procedure in a good way. Now, rather than using recompile sometimes or exec sometimes, I want to do something a little bit different. So when I run this store procedure with some like different values for these parameters, performance is going to be all over the board. Right now on this store procedure only touches the post table, only touches posts, and right now the post table only has the primary key clustered index on it. And when I run this store procedure with different filtering elements and different sorting elements, performance is kind of all over the place. Performance is all muck and wonky, and not necessarily in a way that recompile would fix, because there's really only like one decent choice because I only have the one index. Now, if I've already pre-run these queries because they take about 30 seconds, and I just want to get right to the meat of it. If we run these and we look at the query plans, they're kind of all over the place, right? Like this first one runs for 15 seconds. The second one runs for about 6 seconds and has a missing index request on score and last activity date and include creation date. This next one runs for about 2 seconds, has a missing index on owner user ID, post ID, include score. This one has, this one runs very, very quickly, 46 milliseconds, but has a missing index on post type ID and score. And then this one down here runs at just about 2 seconds again with a missing index on post type ID, score, creation date, last activity date, include owner user ID. So not only do we have sort of variable performance all over the place, but now we're getting attacked by these missing index requests. And this is all stuff that the optimizers is like, well, I need this one and this one, this one. It's like kind of squirrely, right? It's just sitting there like every single possible missing index that it could ask for. It's like, gimme. And that can get overwhelming and confusing because I've seen your tables and they already have dozens indexes on them because just over the years they have accumulated. I'm not saying they're all used or they're all well used or they're all well designed. I'm just saying they're there. They're there. And they're causing problems because you just have too many of them. And now you have this store procedure that you have crafted quite well, right? With all that fancy dynamic SQL, dynamic where clause. You're not messing around. You're not just recompiling every single time. You're not like making them all use the same query plan. You're like, I'm giving you the freedom to choose which query plan you want, and they're all asking for different indexes to make themselves better, right? It's like I assume that's like when like a rich relative dies and everyone's just like, oh, I need that, give me that, give me, right? It's not, it's crappy, right? It's terrible. So The point of this is that, on top of, the fact that you will have all these different query plans and, different things in the plan cache with all these different missing indexes associated with them. It's like, if you wanted to design indexes to make any possible combination of these things fast. So like, this is a pretty limited example as far as like the columns that I'm hitting in the post table, right? Like there are a lot more columns in there, and in real life, these store procedures typically have a lot more parameters to them. You add that to the fact that like, you have a paging element to this, and that paging element requires you letting users sort by different things. They can now sort by any column in the post table in any direction they want. They can sort descending, ascending, they can sort by whatever column they choose. Designing non-clustered indexes to make any iteration of that reliably fast is going to be really, really hard. And it might change over time. You might find that queries that people were searching around for 1 week, the next week they're not searching around for, right? They're just whatever. Right, and then when you want to design indexes, you have to take all sorts of different things into consideration. Like, I have a where clause. Am I searching on equality predicates? If I have equality predicates, so can I put what are people going to order by? If they're not ordering by, where do my inequality predicates go? Where should the included columns be? What should the key columns be? Like, what am I going to do with all of these? Ladies and gentlemen, this is where something like column store indexes can really, really shine, specifically non-clustered column store indexes, because there's no dependence between columns for things. They are stored column-wise, not row-wise, so the order of things matters less. I'm not saying that it never matters. There are all sorts of very rocket sciencey things that my friend Joe Obish talks about, where column order can matter, and for compression and stuff. I'm not saying to ignore it completely. I'm just saying the independence you get really allows you to get better performance from this type of stored procedure. Now, as long as you're on 2012 plus, on 2000, it's not like they're in 2012, but they're read only, and that just blows. So if you're on 2012, just ignore me. If you're on a newer version like 2014, 16, 17, 19, this is generally a pretty good thing to do. Now, remember from running all those other queries, they ran for 2 seconds, 15 seconds, I don't know, 5 seconds, 6 seconds, somewhere in there. So again, performance was all over the place. Performance is never really great for any one of them, right? Performance is never really awesome for any of them. But creating this column store index and having this sort of like one nice blob of SQL Server-y, indexy, column story goodness for all of your queries to use is going to help every single one of these. Why? Because everything that we're searching and ordering on is already kind of lined up for us. Now, I'm going to go and run all of these store procedures now, and I think that's all the ones that I ran before, and we'll see that indeed they all become much faster with that column store index. Of course, I forgot to turn query plans on, so I'll do that again just in case you missed it. Now they are all very, very fast. We're still getting these goofy missing index requests, but we're going to ignore them because we don't need to care about them anymore. There are a lot of zeros on this board now, and I'm very happy with performance. So, is a non-clustered column store index free? Absolutely not. Unlike traditional row store indexes, column store indexes do require maintenance. I don't care what you hear out there on the internet. Column store indexes do require maintenance. If those delta store row groups start filling up, performance can surely tank, and that's kind of what's going to happen when you are using column store index, non-clustered column store indexes over OLTP tables, because stuff's going to be trickling in. You're going to have little inserts, updates, deletes. That's when the delta store row groups start getting all wonky and weird and making performance barf. So you are going to need to pay attention to that. Nico Neugebauer has a great set of Columnstore index maintenance scripts available on his in his GitHub repo. I would certainly recommend that for conquering the Columnstore index maintenance challenges. But if you are if you're in an environment that's OLTP with a reporting element, and or anything where you're allowing people to have this kind of crazy search thing going on, non-clustered column store indexes are probably a better choice than dozens of non-clustered row store indexes when you're trying to get these things to perform well. Anyway, thanks for watching. Hope you learned something. I hope you enjoyed what you saw, and we'll see you in the next video, maybe, probably.